So let's talk about accuracy. Let's talk about aim. How do you aim the ball? Well, if I set the racket down on the ground and I set the ball on it like so, you notice the ball doesn't move. Why doesn't it move? Aside from the fact that, of course, the racket isn't being swung and hitting the ball, the reason it doesn't move is that the force on the racket is due to gravity acting on the ball. So the ball is pushing down on the racket. The racket face is horizontal, and gravity operates vertically at a right angle to the horizontal racket face. In engineering and in physics, that's called the normal force. Normal force is a force at 90 degrees to the surface. Normal, you think, normal, I know what that word means, but it comes from the Latin normalis, which is Latin for carpenter square. Carpenter square is basically a 90-degree angle tool that allows a carpenter to build a building with a vertical stud on a floor plate, or to build a table with 90-degree edges so that you can have a nice rectangular table. So the idea is, if you hit the ball, I'll simulate it by dropping the ball on the racket. You notice I'm dropping it straight down, gravity's going vertical. It's coming back up vertical. So you get sort of a natural power coming off from hitting the racket, coming in at 90 degrees to the racket face, and it comes off at 90 degrees to the racket face. In physics, there's this thing called the angle of reflection is equal to the angle of incidence. So if the incident angle, the angle of the ball coming in, is 90 degrees to the racket face, the reflected angle, the ball leaving the racket, is 90 degrees. If I come in at an angle, if you come in at like a 30 degree angle from the vertical, it'll come off roughly 30 degrees off the racket. So that's angle of reflection is equal to the angle of incidence.